In this video, we will explore the properties of similar triangles, and we will use those properties to find unknown sides and angles. So, when you have a pair of parallel sides like this, it will create similar triangles. So be careful, because I'm talking about this triangle that I have right here on the inside. And then there's an outer triangle that's a bit bigger. All right, so it's a little hard to trace. All right, those are the two triangles in question. I am going to consider the small inner triangle to be the old triangle, and I'm going to look at the larger green triangle as the new triangle. So when I set up my proportions, I always do it in the form new over old is equal to new over old. It doesn't matter which one you call new and which one you call old. You should still get the same answer that I'm going to get. So I am going to set up my new over old proportion right now. Let's start with these corresponding sides, 15 and 27. That's my scale factor. So I'm going to go new over old though. So I'm going to go 27 over 15. So if I want to solve for x, I need to make a fraction out of new and old. A common mistake would be to do this. This is wrong. Do not write this down. A common mistake is to put 4x minus 2 over 20. At a glance, some kids will look at this and think, oh, this is new, this is old. But remember, the 4x minus 2 is just this little piece right here. It is not the whole side of the green triangle. And that's what we need, not just a piece of a side. We need a whole side. So what do I do? What do I do? Well, if I want an expression for the whole thing, then I need to add these. I need to do 20 plus 4x minus 2. These are like terms, the 20 and the negative 2. If I combine like terms, then I'm going to have 4x, but 20 and negative 2 makes 18. So together, these make 4x plus 18. Okay, so when I go to make my fraction, and I'm doing new over old, the new side, the green side, is 4x plus 18. The old is 20. All right, 20 is the red side right there. So this is my equation. I'm going to go ahead and reduce this, so I will have 4x plus 18 over 20 is equal to, both of these are divisible by 3, so this is going to give me 9 over 5. If you're uncomfortable with that, you could cheat and use your calculator. So 27 over 15, 9 over 5. Now I cross multiply. So I need to do 5 times 4x plus 18 is equal to 20 times 9. Now 2 times 9 is 18. So 20 times 9 is going to be 180. Distributive property here, this is going to be 20x plus, okay, whatever 5 times 18 is. So 5 times 18 is 90. Is equal to 180. Subtract 90 from both sides. So that's going to give me 20x is equal to 90. And then divide both sides by 20. All right, that's going to reduce down to 9 over 2 as a fraction, or 4.5 as a decimal. Be prepared to give me either one I ask you for. But in the meantime, let's go back and do something similar for y. Now, I can still use the same scale factor. The scale factor was 27 over 15, which reduced down to 9 over 5. So I can skip straight to having 9 over 5. So now I can concentrate on this. Again, a common mistake is some students will try to go 9 over y. But that is wrong because 9 is only this small piece of a side. It is not the side of either triangle. All right, what we really need is an expression for the full side of the green triangle. All right, we need an expression for this. And that's going to be the sum of these two. So this will be y plus 9. All right, that's the length of the whole thing. So when I do new over old equals new over old, the new side is the y plus 9. It's the whole thing. So I have to do y plus 9 over y. All right, because y is the length of the red side. And then I will cross multiply. So on this diagonal, I have 9y. And then on the other diagonal, I have 5 times y plus 9. Then comes the distributive property. I have 9y is equal to 5y plus 45. And then I subtract 5y from both sides. And that's going to give me 4y is equal to 45. Then I'm going to divide both sides by 4. And I know that does not go in evenly at all. So that's going to leave me with 45 over 4. Or 45 divided by 4 is 11.25. I'm running out of space here. 11.25. Be prepared to give me whichever version I ask you for. All right, number 13 is a mid-segment problem. They're giving us that PQ is a mid-segment of the triangle. That means that LP is congruent to PN and MQ is congruent to QN. All right, because mid-segment means that P and Q are both mid-segments. All right, so one thing that we've learned is that the parallel side, all right, these sides are parallel, by the way. I could put a little arrow here if I wanted to. Okay, the mid-segment is half the size of the parallel side. Or if I double the mid-segment, it should equal the parallel side. So that's where this equation comes from. If I double the mid-segment, that should equal the parallel side. So if I do the distributive property here, that's going to give me 10x plus 16 is equal to 12x minus 20. I feel like subtracting 10x this time just to keep the x's positive for a little while. So that's going to give me 16 is equal to 2x minus 20. Then I would add 20 to both sides. So that'll give me 2x is equal to 36. And then, next thing you know, I divide both sides by 2. And that gives me x is equal to 18. So I can go ahead and record that. Now, if x is 18, I can use that to find PQ. Okay, PQ is equivalent to 5x plus 8. So I've got 5x plus 8. And if x is 18, that's going to be 5 times 18 plus 8. That is 98. So PQ is 98. Okay, we're supposed to find LM. All right, there's LM right there. Okay, LM is equivalent to 12x minus 20. All right, I see the expression. But if x is 18, then I have 12 times 18 minus 20. So that's 196. Okay. Next, we're supposed to find ln. All right, and we have this whole expression right here. So ln is equivalent to 11x. So that's 11 times 18. That's 198. Next, we're asked for LP. So look, if this is 198, and then P is a midpoint, so the two parts should be half of this. So if I do 198 divided by 2, that's 99. So that means that this should be 99 and this should be 99. So LP is 99. And PN is also 99. Number 14 is interesting. John thinks that 3x minus 3 should be half of 5x minus 4. But he's wrong. Explain how you know. Well, John thinks that 3x minus 3 is a midsegment. That would make it half. But he's wrong because a midsegment connects midpoints, like these points should be midpoints. And I know that this point right here is not a midpoint because the two lengths on either side are not the same. All right, if this were a midpoint, it'd be 6 and 6 or 8 and 8. So because it is not connected to a midpoint, it is not a midsegment, so I cannot use the midsegment theorem. And here I just went ahead and wrote up what I just said into a few sentences. Now, Paul thinks he should set up the proportion this way. 3x minus 3 over 5x minus 4 is equal to 8 over 6. But he is also wrong. Explain why. The reason why is because the two triangles, the two similar triangles in this picture, are this inner triangle, right, this smaller triangle right here, and then we have this larger triangle on the outside that goes like this. All right, so the way we solve this is we set up a proportion where we go new over old is equal to new over old. Okay, now looking at the way they're doing the 3x minus 3, they must be treating the small triangle as the new, which is the opposite of what I usually do. And then they're treating the larger triangle as the old. Okay, so new over old is equal to new over old. So we have corresponding sides are 3x minus 3 and 5x minus 4. So 3x minus 3 over 5x minus 4, that's fine. The problem is the 8 over 6. The problem is that one of these numbers is not a side of a triangle. Which is it? The problem is the 6. All right, 6 is not the side of either triangle. It's not the side of the red triangle. It's not the side of a green triangle. It's just a leftover piece of a side. So instead, and this is a very common mistake, but when I want to talk about this side of the green triangle, I need to add these up. So this is going to be 14. Okay. So are we supposed to write this out? All right, I guess we're supposed to explain why in words. All right, so again, I went ahead and wrote up what I just said into a couple of sentences. So now, let's talk about what we should have done. All right, so new over old is equal to new over old. All right, using, if I go ahead and set it up the way that they started to do, all right, or do I want to change and do it my way? I think I'll change and do it my way. I usually just have a habit of considering the small triangle to be old and the large triangle to be new. So now that it's our turn to solve it how we want to, I'm going to do it my way. So I'm going to consider this to be the old, and I'm consider the green triangle to be the new. That's how I usually do it. So looking at the corresponding sides, the bottom of each triangle, new over old would be 5x minus 4 over 3x minus 3. Now, looking at the right-hand side, new over old, the new side, the green side, is 14. All right, not 6, it's the whole thing. And the old side is 8. So 14 over 8. So now we just need to solve this. I'm going to go ahead and reduce this fraction. Right? And in fact, I'm going to go ahead and copy this and bring it down to this space. 14 over 8, this is 7 over 4. So I've got 5x minus 4 over 3x minus 3 is equal to 7 over 4. So when I cross multiply, if I do this diagonal, I'm going to have 7 times 3x minus 3 equals. If I do this diagonal, I'm going to have 4 times 5x minus 4. Then it's time to do the distributive property. So that's going to give me 21x minus 21 is equal to 20x minus 16. Time to subtract 20x from both sides. Nice. That's going to give me x minus 21 is equal to negative 16. Then I will add 21 to both sides. Okay, so that's going to give me x is equal to 5. All right, which is what they told me ahead of time that I was going to get. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.